Hi all, another short but really important set of notes here about math functions. And these are built-in functions in JavaScript that allow you to do some important calculations that are useful in the context of graphics programming. You may have met some of these before in school, maybe not. Okay, first one is ABS, stands for absolute value. Okay, and what that gives you is the size of a number regardless of its sign. Okay, so the absolute value of -5 is 5, and the absolute value is 5 is 5. So it's the same either way. Okay, so we use this all the time in programming. In particular in graphics program, if you want to say, well, you know, what is the difference between these two numbers? What is the size of the difference between two numbers, without worrying about whether or not that difference is negative or positive? For instance, you might want to work out, is one object close to another object? You might take the difference between their x values. That could give you a negative or a positive, but if you get the absolute value of that, then you can tell just easily whether they are close or not by the size of that absolute value. There's a note here about if you want to use this stuff in ordinary JavaScript, you have to use the math object, or actually the math class, well, no, math object, and say math.abs. But for convenience in P5, we can drop the math dot. Another useful function is the square root, useful for calculating the distance between two points using good old Pythagoras' theorem, which should have another S on the end of that, by the way, unless there's multiple guys called Pythagoras. We all know that formula, okay, and it's based on, who cares? Okay, so the formula basically for getting the distance between 2 points is what you really want to know, is the difference between the x values and the difference between the y values, each of them squared and added together, and then the square root of all that. Okay, so that computes the distance between 2 points. This example draws a line from the center of the canvas to the mouse position, and we are going to position the length of that distance along the center of the line. Okay, so you have to, in order to be able to place it along that center, you need to be able to work out, well, how long that line is. And so here is that part of that computation in here, using Pythagoras' theorem to work out the distance between the 2 points. Okay, so next, we can use that distance to work out whether something is actually inside of a circle or not. So you calculate the distance between some point, maybe where the mouse is, and the center of a circle. And if it is less than or equal to the radius, then you're inside the circle. It doesn't matter where you are relative to the circle. If that distance from the point to the center is less than the radius, you're inside the circle. So that means you could make a circular button. Like we had a square button previously, we could make a circular one. Okay, and so this is an example of just deciding whether we're inside or outside of a circular button. Okay, so to make all that easier, because we do it so often, that formula, the good old Pythagoras, has been put into a predefined function in P5, which is one that you'll find handy, which is the dist function, the distance between point x1, y1 and x2, y2. Okay, so this only comes in P5, and so it's a useful simplification. I tend to forget it's there and just use good old Pythagoras myself. That's me. So when you're doing any kind of geometry, you probably have to think about angles, and we've certainly had to think about angles already in the course a bit. So we need to learn two very useful functions, sine and cos. Their full names are sine and cosine. We just refer to them as sine and cos for short, and that's the name of the functions generally that they're named in programming languages. Okay, these functions like to eat radians, but you can change them so that you can work in degrees if you want, with angle mode degrees. Okay, if you want to stick to radians, which is sometimes more natural if you're of a mathematical bent, then there are some predefined constants. Notice they're all in shouty caps. pi, quarter pi, half pi, and 2 pi, which are often ways to express values in radians that you commonly use. Okay. JavaScript only supplies math.py, so you have to be careful where you use these things. They're defined sometimes after your global variables, so sometimes when you try and declare global constants in terms of these things, you come unstuck. Okay, so the sine function is often called the sine wave, and it is the function that varies like this. So if something is sinusoidal, it's often saying it's wobbling on like this. This describes how pendulums swing. It describes what a point on a circle that's rotating looks like from the side. So if you've got a circle that's rotating and you look from the top, you'll see it moving from side to side like it's oscillating like this. Okay, so if you are of a musical bent and you hear a pure tone, then the waveform of that pure tone is a sine wave. Okay. Yeah. So this is very useful code. Hint assignment. This is moving a circle in a circular orbit, okay, around a center x, center y. And the way we're doing it is by using cos and sine and their relationship to it between x and y. Now, these notes aren't very good at explaining this detail. I'm going to make a bonus video that covers sine and cos and what they mean, and also tan and how to undo tan, which is also very useful. So stay tuned for that one. That bonus lecture might be make things a little clearer for you. See ya.